Alright, now let us try to look at the next file, which is where we are going to work with PubMed tools. Now search tools was used to work with clinicaltrials.gov or research studies. This is going to be helpful with working with research papers. Okay, so you can see this file defines the tools that lets the agent fetch live papers directly from PubMed. And why do we need PubMed tools separately from searchtools.py? The thing is, searchtools.py searches papers that are already in our database. Okay, as in the papers we downloaded during ingestion and stored as chunks. PubMedTools.py fetches papers live from PubMed on demand, and this difference matters especially for the side effect checker agent that we're going to build. Okay, it needs to find papers that are published after our ingestion run. A paper published last week about a safety concern would not be in our database, but PubMed has it right now. Okay, so which agents are going to use these tools? Side effect checker are going to use these tools. Fetch papers for trial. Okay, these three tools we are going to basically define here. Okay, which compares the official filings versus the published papers. Then pattern finder agent is going to use this tool, which is search PubMed by query, and this finds the paper that discusses multiple trials. And missing results agent, which is going to use this tool, which is fetch papers for trials. It checks if the results are published in papers, even though they were not posted officially. So these are the three tools that we'll be building now. Okay. Now PubMed allows 3 requests per second without an API key, and on PubMed client already, our PubMed client already handles rate limiting with 400 millisecond of sleep in between. Okay. So we're just going to call all these files here from ingestion.pubmed client. We're going to call PubMed client. We're going to document parser, all of them. Next, we're going to define shared instances. So we're going to just how we defined it for search tools. Now one document parser that is shared across all the tools. Document parser that we're going to define is stateless. It is safe to use or reuse multiple times. And we're going to create one at a module level. So you can see we are creating one shared document parser. Okay, underscore parser, we're going to define it. It is going to be stateless. Okay. Now this, we're going to create an async bridge, which is identical design pattern. Now this design pattern is exactly identical to clinicaltools.py. So same, run async, we're going to have coroutine here, the same thing. Okay, then async I get event loom dot run until complete, and coroutine, the same thing that we have defined, in search tools. Now we're going to start with defining the first tool, which is fetch papers for trial. Okay, what does it take at an argument level? It takes NCT ID and maximum number of papers. What does fetch papers for trial tool do? It is going to fetch all the published research papers that reference a specific clinical trial, okay, which is live from PubMed right now. And this is a primary tool for side effect checker agent, and it finds the papers where the authors reported their findings about a specific trial. Then the agent compares those findings against what official trialing or trial finding says. Okay. And why is this a powerful tool? Firstly, official filings are written by the sponsor. Published papers are written by independent researchers. And when these two sources disagree, which is the sponsor and the independent researchers, when they disagree about safety or outcomes, that disagreement is a signal that is worth investigating, and such niche cases we need fetch papers for trial. Okay, example scenario, let's say the official filing says that no serious adverse events are observed, but the published paper says that 3 patients were hospitalized. So now the side effect checker is going to look at the signal, which is the difference between the two, and it is going to flag this safety gap. Okay, you can see 2 arguments have been taken, NCT ID and the maximum number of papers to fetch. We have set it to by default to 10 if I'm not wrong, right? Yeah, somewhere I think we have defined it to 10. Yeah. Now we're going to create a async function called as fetch. Okay, this is an inner async function which contains all the async logic. We define it here and run it with the run async function below. Okay, you can see here we're running it in run async. Okay. And this pattern keeps the async code cleanly separated from the synchronous tool interface that the LangGraph expects. Yeah. So we're going to use async with, we're going to use the PubMed client, okay, as client. Now here async with opens the HTTPX session when we enter and closes it with the exit, that is a guaranteed cleanup. Okay, then from client we're going to use clients.fetch papers for trial. Basic is the NCT ID. So basis the NCT ID, it is going to search in the PubMed's whatever secondary identifier field and maximum number of papers. Basis that, it is going to fetch the paper trials using the PubMed client, and that will be stored in papers. It is going to return papers. And what this papers output is going to be, it is going to be a list of raw paper dictionaries, and each dictionary is going to have a PubMed ID, title, abstract, and journal. Okay, I think it is also going to have publication date, authors, and NCT ID. So these many things it is going to have, roughly 7 to 8 fields. Okay, then we're going to use this fetch function that we have created here. Okay, async function inside run async, and we're going to store this in raw papers. So we're going to run the async fetch synchronously. Okay, and raw papers is basically the list of raw dictionaries from PubMed. If not raw papers, then it is going to give us an empty JSON. Okay, else now it is used to going to use the parser shared instance. It is going to use parse papers, and what does parse papers do? It is going to process the full list and skips any that failed to parse without crashing the whole batch. So it is going to take all the raw papers. It is going to be passed inside parse papers using the parse object, and this is how we're going to get the parse papers here. I'm going to create an empty list of papers list. We're going to iterate over all the parsed papers. Okay, we're going to use papers.modeldump. Modeldump basically converts the pedantic parser or pedantic parse paper object to plain Pythonic dictionary. Okay, and to this list, paper list that we have created, what are we going to append? So from this paper dictionary, we're going to extract PMID, which is the PubMed ID, title, abstract, journal, publication date, authors, word count, NCT ID reference. All of this we're going to extract from the dictionary, and we're going to append all of this to the papers list. Okay, and finally what do we get in the output? We get a JSON dump, okay, which contains the NCT ID, the list of papers, the count of papers list, okay, and we finally log the exception here. Then we go to tool number 2, which is search PubMed by query. Okay, it is going to take the user query into consideration and maximum number of papers. We are going to set it to default to 5. This is going to search the PubMed with free text query and fetch the matching papers. Okay, so as per the query, which are the matching papers in simple terms. We're going to use this tool when you want to find the papers about a particular topic, drug, or a condition, and not just papers of one specific trial. And this is different from fetch papers for trial, okay, which searches by NCT ID, and this tool accepts any PubMed search query. For example, semaglutide cardiovascular outcomes 2023, metmorphin diabetes safety adverse events, Novo Nordisk, whatever, So the pattern finder agent uses this particular tool, which is search PubMed by query tool, okay, to find the papers that discuss multiple trials from the same sponsor, okay, which is going to reveal the systemic patterns. At an argument level, it takes query and maximum number of papers default to 5. Okay, it is internally, this tool again is used to going to use this async search function. Okay, again it's going to do the same job, client.search paper IDs basis the NCT query ID, okay, and the max papers. If not paper IDs, it is going to return an empty list. Else from client.fetch paper details basis the paper ID, it is going to fetch the paper details and it is going to return those papers. Okay, then we're going to use run async. We're going to use that search function, async search function. We're going to store that in raw papers. If not raw papers, then it just gives an empty dictionary. Else it will take those raw papers, it will parse them and it will store them in parsed papers. We're going to create an empty list of paper list. We're going to iterate over it. We're going to use model dump, and then to this papers list we're going to append all of the data that we're going to extract from the paper dictionary. All of this data that we're going to extract from the dictionary, this will be appended to the empty list. Okay, and finally what does it return? This particular tool returns a JSON dump, a JSON which contains the query asked by the user, papers list which are relevant to the query, and the number of papers that we have gotten. Else it is just going to get the it is going to log the exception. It is going to give an empty JSON in case of an exception. Okay, third and final tool in PubMed tools, which is compare filing versus papers. Okay, and what does it take into at an argument level? NCT ID and filing summary. So my compare filing versus papers is going to fetch the papers for trials and compare them against the official filing. Okay, and this is the side effect checker's most powerful tool. It is going to fetch all the published papers about a trial and then returns the official filing summary and the paper so that the agent can compare them and identify the discrepancies, which is fantastic. What is the agent looking for? It is going to look for safety events mentioned in the paper, different severity levels, outcomes reported in the paper, which are different from primary outcome, and results published. Okay. At an argument level, it takes these two, NCT ID and the filing summary. What is filing summary? This is a summary of what the official filing says, and the agent provides this from the earlier tool calls. What does it return? It returns a JSON with filing summary, papers, comparison note, and paper count. Again, we are going to use the fetch function. Again, the same job. We're going to use the fetch paper for trial. Okay, so which is going to help us fetch the research papers basis the NCT ID and maximum number of 15 papers for comparison. Then we're going to use run async in fetch. We're going to store this in raw papers. Okay, we're going to parse those raw papers, else just an empty list. We're going to store this in a parsed papers. So what are parsed papers? These are basically the clean version of papers, research papers. We're going to create an empty list called as papers list. We're going to iterate over it. To this papers list, we're going to append what? From paper dictionary that we have created here. We're going to extract the PMID, title, abstract, journal, publication date, authors. All of this will be appended to papers list. We have also created one comparison note, which means compare the filing summary above against each paper's abstract. Look specifically for adverse events mentioned in the paper but absent from the filing, different severity descriptions for the same event, outcome results that contradict filing claims, and results data in papers when filing shows results posted equals to true. And this note is basically the guidance for GPT-4o that we are giving. It tells the agent exactly what to look for when we are comparing the sources. So this is a comparison note that we are giving to GPT-4o or the LLM. These are clear instructions in the tool, which means in the tool output, which is going to help us with better agent reasoning. And without this note, the agent might just summarize the papers instead of actively looking for discrepancies. It is going to give us this JSON dump in the output. So when this third tool, the output JSON looks contains NCT ID, filing summary, papers, paper count, comparison note, and does it have the research paper, and it should be greater than 0 basically. Okay. Alright, and finally it takes the exception, and finally what do? We do the tool registry. Again, because we will be using graph builder and our graph builder.py, just how towards the end we did the tool registry here, where at one shot we can access all the search tool. Here also we're going to create all the PubMed tools, where at one single shot we can access all the tools. Yeah. So here we built around 8 tools. Here we have built around 3 tools, which means now we have built 11 tools. Fantastic. Let's go to the next part, which is clinical tools.py.